Welcome back! In our last video, we learned what ML is. Today, we're tackling what is arguably the most important part of the entire ML process, data preprocessing. You will hear this phrase constantly, garbage in, garbage out, or GIGO. It means that if you feed your model messy, incomplete, or incorrect data, you will get a useless, incorrect model, no matter how advanced that model is. This step isn't glamorous, but it's where 80% of the work is done. By the end of this video, you'll know the essential steps to turn raw, messy data into the high-quality fuel our models need. Step 1 is simply understanding what you have. Your data will almost always fall into two types. Numerical, which are numbers you can do math on, like age or price, and categorical, which are text labels or groups like city or color. Once you know what you have, you clean it. The single most common problem is missing data, just blank cells in your spreadsheet. Most ML models will simply crash if they see a blank. The two most common fixes are deletion, where you just delete the entire row, which is okay if you have millions of rows, or the more common method, imputation. This is a fancy word for filling in the blank, usually with the column's average or mean, or its most common value, the mode. The other part of data cleaning is handling outliers. An outlier is a data point that is way off from the others. Imagine a data set of house prices, and one house is listed for $10 billion, or a person's age is listed as 150. These extreme values can dramatically skew your model's results, especially for models we'll see later, like linear regression. You have to investigate them. If it's clearly a data entry error, like an age of 150, you can remove it. If it's just a rare, extreme event, you might use mathematical transformations to reduce its impact. For now, just learning to identify them is the most important skill. This step is a game changer, feature engineering. It's all about transforming our raw data into a format the model can actually understand. And here's the biggest rule. Models only understand numbers. They don't understand text like red, green, or blue. To fix this, we use a trick called one-hot encoding. We create new columns for each category like is red and is green, and just use ones and zeros. Problem solved. The second big problem is scale. If your age feature is 20 to 80, but your salary feature is 50,000 to 500,000, the model will mistakenly think salary is thousands of times more important. Feature scaling fixes this by putting all features on a similar range, like 0 to 1, so they're all treated fairly. This is the golden rule of machine learning, and if you remember one thing, make it this. You cannot test your model on the same data it learned from Y. That's like giving a student an exam with the exact same questions they used to study. You won't know if they actually learned the concepts or just memorized the answers. So we split our data into three piles. The training set is the large pile, maybe 70%, we use to teach the model. The validation set, maybe 15%, is what we use to tune the model's settings. And the testing set, the last 15%, is the final exam that we never touch until the very end. This gives us a true unbiased score of how well our model will perform in the real world. Finally, what if you have a small data set? A simple train test split might be unlucky. Maybe all the hard examples ended up in your test set by chance. A more robust technique is k-fold cross-validation. Here you split your data into, say, 5 folds or chunks, then you train your model 5 times. Each time you use a different fold as the test set and the other 4 as the training set. You then average the scores from all 5 runs. This gives you a much more reliable estimate of your model's true performance. Recap: we learn to identify data types, clean missing values and outliers, engineer features with one-hot encoding, and split our data with the train test split and cross-validation. Now that our data is clean, we're finally ready to build our first model. In the next video, we'll do just that with linear regression. Subscribe so you don't miss it.